Hi guys, my name is Bo. I am from the vSphere product management team. And today I'm very happy to be here to talk to you about vSphere 7 with Kubernetes in VMware Cloud Foundation 4. So this is the standard disclaimer slide. I'm not going to spend much time on this. So on March 10th, we announced Tanzu portfolio and also VMware Cloud Foundation 4, which is helping our customer to build, run, and manage the modern application. So in this VMware Cloud Foundation 4 release, we introduced VMware Cloud Foundation Services, which are Kubernetes and RESTful APIs that help the customer to self-service, create, and deploy all different objects to run modern applications, including container applications. So today I'm going to show you at the corner, at the center of this whole service, the vSphere with Kubernetes. How does that work, and what are these services? So the first thing I want to show you is what is a modern application that we're talking about here. So a modern application is different from traditionally a application are basically just the virtual machines. Here you might have containers and virtual machines and sometimes some serverless application like function as a service. So when you look at these type of application and then consider two of the largest user group for vSphere, including DevOps and the vAdmin, their focus are very different. So developers, they build application, they operate these application on the vSphere platform, and they support them over the life cycle of this application. For vAdmin, they care about the availability, security, quality of service. Can I meet my SLA goal for these applications? And also, of course, the cost. So how do we build a tool to help these two different user groups to do their job, and also they can collaborate together? That is the goal for the vSphere with Kubernetes. And the way we want to do that is by leveraging Kubernetes. So first, let's say that how do we solve this for developers? So imagine when a developer comes down to deploy such an application, they can just use the standard Kubernetes interface, kubectl, to say kubectl create a Kubernetes cluster for me. And then with a YAML file, you can specify how many worker nodes, how big the worker node is, and what Kubernetes version I want to have, all of these attributes. And also the same thing goes to if I don't want to manage my own cluster, but I just want to run my container workloads, and I can just use kubectl again to say create a pod or a deployment replica set to run my container workloads on this platform. And then the vSphere platform is going to create the pods that runs directly on vSphere cluster, and which I will show you in just a second. And also, we're not stopping there. We're going to make a virtual machine service available. This allows developer to use the kubectl interface to create and manage virtual machine objects.
So, Paul, can we stop here for a second, because I think we were glossing over a couple of things that I'm sure that you guys considered because of your experience working with traditional enterprises and those applications, those VM-based applications you talked about in the past. One of the constructs in Kubernetes is this concept of operators and developers. The enterprise doesn't split as cleanly into those two categories. We kind of have app owners, and we have developers, and we have IT infrastructure folks. So who in the enterprise do you envision using these kubectl commands? Are these the app teams? Is it the developers themselves, which is kind of non-traditional in most enterprises?
Right, that's a good question. So this really depends on the organization of the customer. So we're saying some of the customer, their developer team, they are actually the user who not only build application, but also they deploy this application and manage that on the vSphere platform. So, in that sense, a DevOps model, if they're adopting that very well. So everybody who, they build application, they also operate their own application. But we also see in some customers' organization, you will see the model where a group of team, they mainly focus on build application. They are the developers, but also they have a operation team that this team is kind of their focus is to deploy these applications that built by developers and then maintain that on the platform. So we see a few very different model of how the customer are adopting DevOps model, but I think here is like the focus is whoever is going to deploy and operate this application on the vSphere platform. So they will be the target user for these kube control interface.
Hey, just to add to that, one thing is that the cloud admins don't have to use the kube control interface. That's very important. They continue to operate the way they are operating today with vCenter, STDC Manager. So that's very important. They retain their operational model and the tools that they are familiar with. And that's the best part about this product.
Yes. Thank you, Ranjit. So,
hey, Bo.
Yes.
Real quick. So you actually showed where you can define in the YAML config where you can deploy the cluster. Where you define the version, are you guys using which distribution? I mean, not that it really matters. I'm just really curious what distribution you're using. Is it the VMware branded version? So I don't have to worry about, hey, I need to use this, et cetera, et cetera.
Exactly. So the built-in version that in this release is the Tanzu Kubernetes Grid.
Okay.
So that's the TKG version.
Okay.
Yeah.
Cool. Thank you.
Absolutely. So another part of this, the reason we're embedding Kubernetes here is we find out the namespace object in Kubernetes is a great thing that we can leverage to help VI admin to manage all of these workloads. So in the way we see how this works, if you put all of these components for one business application into one namespace, and then from VI admin's aspect, all of the policy that you used to set on a per VM basis, now you can set that to the namespace. So you have a way less object to manage. And then within the namespace, the developer groups can do everything self-service. And then, so in this case, when you look at a list of namespace from a VI admin's aspect, you are looking at a set of business applications. So in this context, it's going to be much easier for you to make a call to say which application is more important and which one need to be encrypted and so on. So now let's take a look at all of these services, the VMware Cloud Foundation Services. So you can see all these things runs on the vSphere platform, so vSphere with Kubernetes, and then a vSphere cluster become a supervisor cluster in this release. I will show you how do we actually embed Kubernetes into vSphere cluster in just a second. And on that, you have all of these services, including the Tanzu Kubernetes Grid service, vSphere pod service that we just showed. So from this angle, the developer can use these services and by talking to, use the kube control interface and then self-service create all of these objects, including a Kubernetes, a cluster, a pod, virtual machine, and router, all of these objects within a namespace that this namespace are managed by VI admins. And most importantly, I want to point out that the interface that developers are using here is the standard Kubernetes interface, kube control. So this is like, we're not asking them to pick up a new tool, and this is the interface that they are familiar with and they like to use. At the same time, all of the things that been created and deployed by developers on the vSphere platform are visible to VI admins, and VI admin can manage all of these objects through vCenter and the vAPI. Again, the interface we ask the VI admin group to use is the interface that they are familiar with and they like to use. So now let's take a look at how are we actually making a vSphere cluster into a supervisor cluster. So this is a diagram shows that a vSphere cluster which has 3 ESXi hosts. And then with vSphere with Kubernetes, the first thing to turn this into supervisor cluster is that we're going to deploy a set of a Kubernetes control plane VM. We deploy 3 of them for HA, and then we also deploy an agent called a Spherelet. So this is basically our version of Kubelet. So Spherelet runs on every ESXi host in this cluster that essentially make every ESXi hypervisor into a worker node of this cluster that managed by Kubernetes control plane. So now with this setup, a DevOps user can talk to the Kubernetes control plane to say, kube control, deploy a pod for me, or a deployment. So these pods will be created directly on the ESXi hypervisor. It's different from the pods that normally you would see that will be running on the Linux VM. So these pods are a little bit special. We actually built a native runtime for ESXi hypervisor. So we take the VMX, which is a process register, a virtual machine on the hypervisor, and we optimize that for the container workloads. So we call that a CRX. And on top of that, we put a thin layer Linux kernel and then a container engine. So this is your native container runtime on the hypervisor. And so running your containers on this with this object will give you the benefits of the security isolation, because from the hypervisor's aspect, multiple pods here, they are actually isolated by the hypervisor. So they're almost like a two completely separate virtual machine runtime. And also our performance shows that these pods are 8% faster than the pods running on bare metal environment, because ESXi does a better job on CPU scheduling compared to Linux OS.
Although I have a question related to the Kubernetes control plane VM. Do they include the API server, etcd, controllers, and so on?
Yes, all of those things are deployed as part of the Kubernetes control plane VM, as shown on this chart.
So when you deploy a supervisor cluster, each node is basically each ESXi node is basically a worker node, but at the same time it contains an instance of all the management control plane of the Kubernetes cluster itself, right?
Yes.
Thank you.
Yep. All right, so this is the layer that we call as the supervisor cluster. And this is the foundation of this vSphere with Kubernetes. And so we deeply embed Kubernetes into a vSphere setup. So the next thing I want to touch on is the Tanzu Kubernetes Grid service. So this is the goal, to put Kubernetes ubiquitous and put it everywhere, and it should be standard. So in this case, you can see that in the supervisor cluster down here, that we have a few different operators running there. We have a virtual machine operator, and we have a TKG operator, and also cluster API, so which is a open sourced efforts that managed by the Kubernetes community. So with this setup, and we have the Tanzu Kubernetes Grid service running on the supervisor cluster, as a VI admin, I can define which standard Kubernetes template or version or topology that my developer are entitled to use. So I can manage from that angle. And then a developer, they can just use kubectl to talk to this TKG service on the supervisor cluster, and then they can immediately create a TKG cluster. And then they can talk to the cluster directly to deploy their application. So this is the way that a developer can self-service create a standard Kubernetes cluster, and then deploy and manage their application running inside this cluster. So this chart shows that all of these different components that work together to fulfill the requirements from a developer to create a Kubernetes cluster. And also, if you would like to build a more customized Kubernetes cluster, you can actually also talk to a lower layer API to fulfill that requirements. All right, this is a different angle to look at this, and to make sure that we show like all the components we're introducing in this new release. So at the bottom, you can see the SDDC, and this is your compute, network, and storage. And in this case, let's say you have two vSphere cluster. Now they become two supervisor cluster. And then within supervisor cluster, you can create a namespace. And in the way that we're imagining how this should be used, a namespace should map to a business application. Within the namespace, a developer can self-service deploy pods. So these are the vSphere pods that runs directly on the ESXi hypervisor, and it gives you the benefits of the very strong security and resource consumption isolation, and also better performance. And also, you can have more namespace, of course. And with the virtual machine operator that running on the supervisor cluster, a developer can deploy not only pod, but also virtual machine as well. And this virtual machine operator is not available today yet, but it will be available soon in a future release. And you can, of course, deploy more virtual machines on in the namespace. And then there are two other components, like two other operators running on the supervisor cluster, the cluster API and also the Tanzu Kubernetes Grid manager. In this case, when a developer requests a Tanzu Kubernetes a cluster here, that all of these operators in the supervisor cluster is going to work together to create all of these virtual machines and then configure them into control plane node, worker nodes, and also stitch that together into a Kubernetes cluster. So this is the TKG cluster. And then a developer can start to use this cluster to deploy and run their application.
Another question, Bo. So my understanding is that the supervisor cluster is made of physically ESXi cluster. The Tanzu Grid clusters is made of virtual machines that are instantiated on the fly and that represent Kubernetes nodes, right?
That is correct.
Thanks so much.
Can we go back to that slide you were just building with the? So this is just a little bit, well, a lot confusing to me. So starting as the SDDC layer, that's the concept. That's my compute storage network, etc. The traditional VMware SDDC concept or construct. Then we move up to the supervisor cluster. Are we saying that there's two different types of supervisor clusters? That's what's been represented here?
No, sorry. So in this case, I'm just trying to show the relationship between all of these different components. So in one vCenter, for example, you can actually have multiple vSphere clusters. So that's why in this example, I just showed that, assume you have two vSphere clusters here. So you can make them into two supervisor cluster. You can, of course, have 20 supervisor cluster here as well. And also you can have a mix of, regular vSphere cluster, which does not have this supervisor cluster enabled, and to mix with other vSphere cluster, which are supervisor cluster today. So this is just to show you the relationship between the SDDC and also the supervisor cluster and the namespace and all of the objects you can deploy within a namespace.
Okay, so overall, the concept of namespace is very new to vSphere and vCenter directly, and that's not necessarily Kubernetes related. That's just capability of bringing namespaces to vSphere. But the other thing that confused me a little bit is that the concept of a pod outside of Tanzu Kubernetes cluster. So I can create pods that are independent of Tanzu. So if I want to manage them with another platform, I can manage these Kubernetes pods with a different platform other than Tanzu.
Right. So yeah, basically when you run container workloads, you have two choices. One is you can create your own Tanzu Kubernetes Grid cluster, and which use virtual machines as the worker nodes, and then you can deploy pods in these clusters. But at the same time, if you don't want to manage your own cluster, you can directly deploy container workloads onto the supervisor cluster. So that is using the vSphere pod service. And then so these pods runs directly on the hypervisor. And that is the one that we should show that the native runtime that we built for the hypervisor.
So when I'm not using Tanzu cluster, when I'm using a different management control plane to provision pods, are those just Kubernetes compliant APIs?
Yes, so the API is completely Kubernetes compliant. So, but the supervisor cluster today, when you run your container with the vSphere pod service, so it's not 100% conformant yet. There are a few different things because the worker node is a ESXi hypervisor. So there are some opinionated implementation here. Mainly, there are three things. One is the host pass volume is not supported because the worker node is not a Linux OS. But this is not a big problem because the host pass is not actually recommended for security reason by the community. So I don't see that's a big problem. And the second thing is the privileged container. It doesn't really work the way as when you run a pod with a Linux VM, because in a Linux VM, pods are isolated by C group. So when you create a privileged container, you can spy on other containers, even these container runs on other pods, as long as you are on the same worker nodes. But here, because of the very strong security isolation, so this is some trade-off that a privileged container can only see the container within your own pod, but you cannot really see other pods, even they're on the same worker nodes, because the isolation is so strong. And the third thing is the deployment set. So where, but the goal here is to make the supervisor cluster 100% conformant over time.
Okay, and then the big question I hope you guys get to is this whole introduction of namespaces in general to vSphere. If I'm moving from vSphere 6.7 update 3 to 7.0, and this is super important for those of us that are consuming VMC on AWS, what changes operationally? If I don't want if I have no interest in containers, will my current VMware vSphere operations work exactly as it is today? And I'm just deploying VMs, I'm using Active Directory as my pseudo namespace today, et cetera, et cetera. Does that all just work?
Yes, so thank you for asking that. So when you have this feature, first, you can enable the supervisor cluster, this workload management feature on an existing vSphere cluster, which has traditional VMs running on that. So you don't have to have a dedicated new cluster created for this. And also, even if you enable this on a cluster, that all of the things you just mentioned that you can do today, you can still operate that in the way that you are doing, as of today, if you're not using the container workload here. So yeah, it's not forcing you to change any operation model, but if you want to take advantage of these new namespace construct to manage your workloads, to allow your developer to self-service create these workloads within a namespace, you can leverage this new feature and capabilities.